So we've learned what a chemical equation is and what it represents, and so now we're going to learn how to write balanced chemical equations. So these are the instructions. We'll read through them, but it's a little bit like reading instructions for a board game, right? You read them through and you don't understand them until you start playing the game. So we start out by writing a skeleton equation. We just need the correct chemical formulas. It's really important to get the correct formulas because if those are wrong, the whole thing's going to be a mess. If you have an element that has only one, occurs in only one compound, they suggest that you do that one first. If there's more than that, balance the metals before the nonmetals. My approach actually is just to start with the first element. It works most of the time. This is a technique called balancing by inspection. And so sometimes you start in one place and you realize it's not going well, so just start over somewhere else. There's not one set of rules that if you follow it, it'll go beautifully every single time. So it's kind of a crapshoot, really. If you've got an element that is a free element, so it's just by itself, like O2 or aluminum, leave that one for last, because when you balance that, it won't mess up anything else. And then if you end up with fractional coefficients, you need to clear those out by multiplying by an appropriate number. Most of the time we can actually avoid having any fractional coefficients, and I'll show you how to do that. And then always check and make sure that it's balanced, because sometimes you make a mistake as you're going along and you don't realize it. So double check. So these two things here are very important. Do change coefficients to balance the chemical equation. So once you've got those formulas in place, you can write numbers in front of them, but that's all you can do. Do not change the subscripts on the formulas. Two very important points. So let's practice. Write a balanced equation for the reaction between solid chromium-3 oxide and solid carbon to produce solid chromium and carbon dioxide gas. So the way these questions are set up, we're going to also be practicing our nomenclature. On an exam, these skills are separated. There will be questions that ask you to write names and formulas of compounds, the nomenclature. There will be other questions that ask you to balance the equation. But here we're just going to combine the two and get some practice. So we've got a sentence and we need to turn this into a chemical equation. First thing is getting correct formulas. So as we look through this, this is a sentence representation of a chemical equation. So we have a reaction between. So we've got solid chromium-3 oxide and solid carbon. So this and is like a plus. To produce is the arrow. So that's what we're making, solid chromium and carbon dioxide gas. So there we've got it in words, and we need to make the formulas. So chromium-3 oxide. The Roman numerals should be the big tip-off that this is an ionic compound, that this is a metal. So to write the formula for an ionic compound, you need the formula for the ions with their charges. So chromium-3, the 3 is the charge on chromium. It's not how many there are. Oxide is an ion formed from oxygen. And we can tell from the periodic table that the charge is 2-. So then when we put those two together, we can do that crisscross charge. We get Cr2O3. They're telling us that this is a solid. So then in parentheses, we write S for solid. Any questions yet? So that is reacting with solid carbon. I'm going to leave a little bit of space here in case I need a coefficient. I'm going to write the formula for carbon. That's an element. Is it one of the 7 diatomic elements? No. Horses need oats for clear brown eyes, but that C is C-allyl, and that's chlorine. So carbon is just C, and it says it's a solid. And then we've got the arrow, and we're forming the solid chromium. This is also an element. Is it diatomic? No. Just solid. Plus, so carbon dioxide. Carbon and oxygen, both nonmetals, is a molecular compound. We've got the prefix here that tells us there's 2 oxygens. So CO2. And then in parentheses, G for gas. So any questions about that? Now we're going to balance it. Yeah, question?
The ones on the left are the reactants, correct?
Yes. So these are the reactants. That's what we start with. Those react, and they produce the products. And so the arrow points to what gets formed. And it's, left to right, just like we read. So now what we're going to do is we're going to look at this and see what we've got. So, like I said, I like to start with the first element. So here I've got Cr2. I've got 2 chromium atoms on the left side of the arrow. How many chromium atoms are shown on the right side? Just 1, right? There's 1 here. Well, I can't change the subscript. I can't subtract anything. I can only add more. So if there's 2 over here, then I must make 2 of these. And so I can put a coefficient in front of that. So now I've got 2 chromiums here and 2 chromiums there. Here I've got 3 oxygens. Over here I have 2 oxygens. Well, I could use a fraction. I don't know very many students who like throwing fractions into balancing equations, so we'll not do that. So what could I do here? I have an odd number here and an even number there. This is what I call the odd-even problem. So what happens to an odd number if you double it? It becomes an even number. So if we double this, it'll be 6, and then that's an even number. So I'm going to take this guy and double it. Now I've got 6 oxygens, and I've got the 2 over here, so I could put a 3 in front of that. Now I have 2 times 3, 6 oxygens here, and 2 times 3, 6 oxygens there. So I fixed the oxygen, but what did I mess up? I messed up the chromium. So I need to pay attention and go back and fix that. Now I've got 4 chromiums here, so I need to change this coefficient, right? So I'm just going to erase that. Balancing equations should be done in pencil. There will be many erasings. And I'm going to put a 4 here. Everybody okay with that? So I fixed the chromium and the oxygen. The carbon here is all by itself, and so that's a good one to leave for last, because when I mess around with that, I don't change anything else. So I've got 1 carbon on this side, and there's not any here. How many carbons in this guy right here? 3. So if I put a 3 over here, then I'll be balanced. Yes, there is backtracking. And sometimes it feels like not even backtracking, it's just going in circles. Sometimes you find yourself going in a circle and you keep changing coefficients and changing coefficients. Then you should stop and make sure your formulas are correct, because if you have a formula that's wrong, it may be impossible to balance it. The other thing, if your formulas are correct, just start over, start with a different element. Because many times there is one element that it's easiest if you start with that one. The thing is, you can't always tell which one that is, so you just have to start somewhere. So any questions about this one?
So will the reactants and the substances always be given to us in a problem?
The reactants in the products will generally be given. So when we're asking you to just flat out balance an equation, we'll give you all the reactants in the products. We are going to learn how to predict the products for specific types of reactions. So, but that's going to come up in a bit. Okay, let's do another one. Whoops, let's not skip that one. I did that one. Okay. Write a balanced equation for the combustion reaction of gaseous C4H10 and gaseous oxygen to form gaseous carbon dioxide and gaseous water. A very gassy problem. Bless you. So we're giving you this formula because that's a compound that we haven't learned how to name or write a formula for, but the rest of them we should be able to do. If you're doing homework problems or worksheet problems like this, try to write the formulas using your own knowledge. Try to work out the nomenclature. And then before you start balancing it, look up the formulas. You know, carbon dioxide. You can find the formula for carbon dioxide online. But you should try to get it yourself and then use the internet to check your work. Yes?
If I found like the fractions, can I use it for fractions like that?
You can balance it with fractions. That last one we could have put 3 halves, and that would have balanced the oxygen. So then after you get it all balanced with fractions, you need to look at your denominators and multiply by 2 on everything to clear the fraction. So a correctly balanced equation has whole number coefficients, and they're the lowest ratio. Good question. Okay, so let's do this one. Bless you. So combustion reaction of gaseous C4H10 and, that's the plus, to form, that's where the arrow is, and the other and is the plus.
So the end's always in plus?
Yeah. So we're going to have this and that, and I mean there could be only one reactant, there could be 5 reactants. But they'll be listed in order, the reactants, you know, reacting, usually separated by and, or sometimes with. It'll say this reacts with. And then there'll be some sort of a transition to form or to produce or makes, and that's where the arrow is. And then the others will be separated by, I don't remember the term for that type of word in English, but and, with, something like that. Okay, so C4H10. C4H10. They're telling us it's a gas. That reacts with gaseous oxygen. So oxygen is O. Is it a diatomic element? Yes. Horses need oats. So it's O2. This is where we really need to pay attention to those diatomic elements. If you have one of hydrogen, oxygen, nitrogen, chlorine, fluorine, bromine, iodine, and this one, I don't think I did, by itself, the formula has a subscript 2. If you don't write the subscript 2, that would be considered incorrect. So O2, and they tell us that's a gas. So we put G here. And then the arrow, carbon dioxide. Okay, so we already saw carbon dioxide. Whoops. CO2, and that's a gas. And gaseous water. What's the formula for water? H2O. And that's in the gas state. Now we need to balance this. So I'm going to show you another technique. And you just need to kind of find your own style for balancing equations. So in the last one, we just kind of looked at it and took care of things. Some of them get a little more complicated. Like in this one here, we've got oxygen, oxygen, oxygen. We've got oxygen in multiple places. So this is another way to do it. Just draw a line at the arrow. And we need to make sure that whatever's on this side is the same number of things as on this side. And we're just going to kind of take inventory. So we've got carbon, hydrogen, and oxygen. I'm just going to write carbon, hydrogen, and oxygen here. And I'm going to go and see what I've got before I start throwing coefficients in here. So in C4H10, I have 4 carbons, and I have 10 hydrogens, and I have no oxygens. Over here with the O2, there's no carbons, there's no hydrogens, and I've got 2 oxygens. Everybody okay with that? CO2, 1 carbon, no hydrogens, and 2 oxygens. And then for the water, no carbons, 2 hydrogens, 1 oxygen. This is just a technique I came up with that seems to help when things get a little more complicated. So now I've got it all written out. I can look at carbon, and I see on this side of the line I've got 4 carbons, and over here I only have 1. So that means I need to make 4 CO2s, and then that's going to multiply everything below it. So 1 times 4 is 4, and 2 times 4 is 8. I'm just sort of keeping track of what I've got. Now I have the same number of carbons on each side. And I'll just go down to hydrogen. On this side I've got 10 hydrogens. Over here I've got 2. So I need to multiply that by 5. So 2 times 5 gives me the 10, and 1 times 5 gives me 5. Then I go down here to oxygen. I have 2 oxygens on the left. I have 8 plus 5 on the right. That's 13. So how do I get 13 oxygens when they come in pairs? This is like going to the shoe store and saying, I need 13 shoes. Not 13 pairs of shoes, I need 13 shoes. And they're going to say, you can't do that, right? They won't sell you half a pair of shoes. Well, this is where you can use a fraction. If you need 13 out of pairs, then you need 13 halves, and that would balance it. Then you'd need to go through and multiply everything by 2. So if you like that, that's what you can do. I'm assuming most of you don't like fractions. I have a friend who teaches middle school math, and she says fractions are the F word. And that's how a lot of students feel. So we're going to avoid fractions when we can. So 13 is an odd number, 2 is an even number. This is the odd-even problem. So we can get rid of that by doubling things. I've already done a lot of work here. I don't want to screw it all up, right? So the O2 is all by itself here, and that's what I'm messing around with. If I double both of these, and I double this one, it's still going to be balanced, right? So that's what I'm going to do. Let's use a different color here. So I'm just going to double things now. So that makes this 8 and 20. It's okay that that's a big number. This is what I'm messing around with, so I'm going to leave that one alone. I've already fixed this one. I'm going to double that. I'm going to make this 8. And then this becomes 8. And this becomes 16. I'm going to double this one. That becomes 10. So that doubles all the stuff down here. My carbons are still balanced. I just have twice as many now. 8 and 8. My hydrogens, 20 and 20. Do you see what I did? I doubled it. Now, I still have this guy because I haven't fixed him. But now I have 16 plus 10. That's 26. That's an even number, right? So now, if I put a 13 in here, 13 times 2 is 26, and I have 16 plus 10 equals 26, and it's balanced. Any questions? You don't have to do this tally method, but some students find it helpful. This is one of those things you have to practice. So when you're all done at the end, look at what you've actually written. So carbons, I've got 2 times 4 is 8 on this side, and I look across and over here, there's no carbons there, but here I have 8 carbons. So that's good, that's the same. 2 times 10 is 20 hydrogens. Over here, 10 times 2, 20 hydrogens. Here I've got 26 oxygens. This is 2 times 8 is 16, plus 10, 26. Sometimes students will go through this process and they'll overlook something, and then they don't go back and check. They did a lot of great work, but they still come up with the wrong answer. Always go back and look at your final answer. Any questions? Write a balanced equation for the reaction of aqueous lead-2 acetate with aqueous potassium iodide to form solid lead-2 iodide and aqueous potassium acetate. So here I've got something reacting with, those are together to form this and that. So the first one, lead-2 acetate. So lead-2 is Pb, 2 plus. My stylus is breaking. Acetate, that's when you have to memorize. C2H3O2 minus 1. So when I put these two together, I need 2 of the acetate ions to balance the charge on the lead. C2H3. And what's the state symbol? AQ. It's aqueous. It's dissolved in water. Plus potassium iodide. What's the charge on a potassium ion? Plus 1, because it's in group 1. What's the charge on iodide ion? Minus 1. Again, from its position on the periodic table. Here, the charges are the same in magnitude, opposite in sign. We just shove them together, and it's a good formula, Ki. Also aqueous, so we put AQ, and there's our arrow. I'm writing too big, and I'm running out of room. Now we've got solid lead-2 iodide. So now we've got lead-2 and iodide. So this is a -1 charge. So this is going to be PbI2. And we're told that this is a solid. And then we've got aqueous potassium acetate. So that's K plus with acetate. So that's KC2H3O2. Yeah, I ran out of room. I'll put it up here. Aqueous. Well, that's pretty ugly. Not going for beautiful, but I'm just not crazy ugly. So, any questions? Now we're going to balance this. So this is acetate, right? C2H3O2. And then over here we have C2H3O2. It didn't come apart, did it? It just switched partners. So if we want to, we can balance this as a unit, or we can treat the elements separately. Both ways can get you the correct answer. I prefer to see it as a unit because it's a lot faster. So let's just start at the beginning and look at Pb. So on this side of the arrow, how many lead atoms? 1. Okay. On the right side of the arrow, how many lead atoms? 1. Awesome. That's already balanced. Okay, so C2H3O2. How many of these ions are here? There's 2, right? That's what the parentheses and the 2 on the outside means. How many acetate ions are over here? Just 1. So if I put a 2 in front of that formula, then I'll have 2 acetate ions, right? So I've got 2 acetate ions here, 2 there. This is 4 carbons, 6 hydrogens, 4 oxygens. Now over here I've got 4 carbons, 6 hydrogens, 4 oxygens. Next up is potassium. There's 1 K here. How many Ks over here? 2. So I need to put a 2 in front of Ki. I can't change the formula. I can only put coefficients. So now I've got 2 Ks, and how many I's? 2 I's and 2 I's. Any questions?
Do you have to put one in front of the other one?
That's a good question. Do you need to put 1 in front of the other one? No. Chemists don't like to write the number 1. So we understand that there's 1 of these because we didn't write another number. And the same for this first one. If you write a number 1 there, I'm not going to mark it wrong, but it's not necessary. I'm not sure what Master in Chemistry would do with that. Let's do another one. So this is more like what you might see on a test, where you're given the skeleton equation and you just need to balance it. So again, I find it works much of the time to just start with the first element. So how many H's on the left side of the arrow? 1. And how many H's on the right side? 2. So how do we fix that? Let's put a 2 in front of HCl. I got 2 H's and 2 H's. Let's look at Cl, because it's next. Now I've got 2 Cl's, and how many over here? 2. Oh, that's nice. Now let's get to oxygen. I've got O2, that's 2 oxygens, and how many oxygens here? Just 1. So I need to put a 2 in front of the oxygen. I'm sorry, the water. Now I've got 2 oxygens. This is where I think some students stop, because they're like, I went through all the elements. Yeah, but we just screwed up hydrogen, didn't we? When I put a 2 here, I fixed the oxygen, but I messed up the hydrogen. So I need to go back and fix that. So I have 4 hydrogens now, so I need to go over here and change that to a 4. And what did that mess up? The chlorine. So 4 chlorines, I need to change this. I need to put a 2 over here. Thankfully, that one didn't mess up anything else. If it messed up something else and you went around in circles again, you should stop and do something different. But sometimes you do have to go, once or twice around in a circle. That is not the only way to arrive at the balanced chemical equation, but we should all end up with the same balanced chemical equation. This is one of the things I like about many aspects of chemistry. There is one correct answer. That's what I like about math. 2 plus 2 is 4. We don't have to debate what it is. Any questions?